Okay, good morning everybody. We're here again working on our Flame Wheel F450 / NAZA group build, and what I'm going to talk about this morning is mounting custom motors to your arms and then cutting the wires and putting new bullet connectors on. When you first buy your F450, if you happen to have bought the ARF, you got these motors, which are the DJI 2212-920 brushless motors. They come with short motor leads that already have the bullet connectors attached, which work great if you're going to mount these, feed them through the arm, and then just plug them into the ESCs the way you're supposed to. With my build, what I decided to do early on was use Tiger 2216-12 motors, and these are 600 kV. And I just happened to have these in the shop. I had 4 of them from a purchase I made last year, so I decided to use them. And in order to do so, I've had to make a small modification because they come with very long wires. Okay, and these are some of the wires that I've already cut off. So what I'm going to talk about this morning is getting the wire to the right length, cutting it, stripping it, putting a replacement bullet connector on, and then getting it all mounted to the arm so it's secure and so it won't cause problems down the road for you. So first couple things that you're going to need. We talked earlier in a video about a wire cutter and wire stripper, so we're going to need that. I like to use pliers, like I've said before, with elastic bands. So I'm going to use this to hold my bullet connectors, and the elastic band is not on there so tight that it's going to smash the bullet connector, in case anybody's saying that's a bad idea. If I'm doing a lot of bullet connectors, I have a block of wood with some holes drilled in it, and I'll just stack them up and just do one after another, kind of like a production line thing. And then I also have some heat shrink tubing. I have a small size, which we're going to use to insulate our replacement bullet connectors, and then I have a larger size that we're going to use just to put around the wires so that when we zip tie them to the arm, they won't chafe. They won't. The insulation won't get damaged by the zip tie. All right, and then I also have a little Dixie cup with some denatured alcohol. I have a toothbrush to clean my solder points. I like to use a silver Sharpie for marking wires and stuff. It's very easy to see when it's on a black wire. And I also have, this is called backer rod, and it's a very kind of springy, dense foam. You put this in a crack before you caulk the crack, and it supports the caulk so the caulk could do its job without cracking and coming loose. But what I use it for is I cut it up into different sizes and shapes, and you'll see when I mount the wire to the arm, I'm just going to put a little piece of foam underneath it so that wire is bedded on the foam instead of being tied up tightly against the plastic. Okay, and again, that keeps the wires from chafing, it keeps the insulation from being broken, and you could also see there where I have a piece of heat shrink tubing on all 3 wires with the zip tie over the top of them. Okay, so the first thing you're going to do is you're going to take your wires from your motor and you're going to feed them down through the frame. I give them a few twists, and then also from that point you're going to give them a few more twists, and these wires have already been cut kind of to a rough length, but now we're going to cut them to the exact length. So if you were to take the wires and pull them tight and then mark it, I've got paint on my sleeve, that's what you see there. So that's where they're going to have to be cut if you wanted to pull them really tight. If you left them really loose and floppy, you might mark them right about there. Alright, so you see there's an inch difference there, almost 3 centimeters. So somewhere in there is the right length, and you'll see that if you pull them tight, right, to where that first mark is, if you only let them go a little bit so that they're a little bit loose in the frame, but not all over the place, you only need like another 1/4 of an inch or so. So what I'm going to do is I'm going to mark the wires right about there, and I have them twisted already while I'm doing this, because if they were not twisted, if I were to cut them and then twist them, chances are they'd come out too short. So I'm not twisting them super tight. It's not like we're winding the rubber band on a free flight model here. We're just giving them a few twists so they stay together. A little bit loose. That's what they look like tight, and that's that mark right there. So a little bit loose. Mark it again. And that's where we're going to cut them, okay? So I'm going to cut them. And then I'm also going to strip them. Okay? And as soon as I'm done stripping the wires, I am going to tin them. Okay? So they're stripped. The bare wire is hanging out. I'm just going to do this right here. I'm not going to clamp it. I'm just going to put the soldering iron up against the wire, get it warm. The soldering iron is set to 800 for this. Okay. And just like I said in the other video, when you're tinning the wires, you don't want to just keep pouring more and more solder into them, because you don't want the solder going up underneath the insulation, causing the wire to become very rigid. Okay, so this last one. Give it a chance to heat up. You see the solder goes right into the wire. Okay, so it's doing its thing. Now we're going to flip this over. We're going to pull the wires out, separate them again, and we're going to put them into the bullet connector. So what I do is I take the bullet connector and I put it into my pliers. Put it into position there, and this is a little awkward the way I'm doing it because I'm trying to make a video, but let me zoom in a little bit. That right there, get rid of these wires. Okay, right there. Bring this around. So now the first thing with these bullet connectors is you want to get them warm. So we're going to put the iron on there for a few seconds. A little touch of solder just to help the heat get from the iron into the metal of the connector. Now we know it's hot, so I'll fill up that hole in the bullet connector halfway or so, and then get my wire, put it down into there, put the iron back on it, because now the wire has to be brought up to temperature. I might add a little more solder, but in this case I see there's a lot of flux boiling in the top of that pool of solder. So a little more heat, and then you hold it perfectly steady. And I blow on it to help it cool off more quickly. Okay? Now another way to do this, if you wanted to save yourself a little bit of solder, you could hold this sideways, lay the wire on the side, and then just put enough solder in so that the solder bonds the wire to the side of the bullet connector, and then your wire just comes out of the bullet connector a little on the edge like that. I do it upright, and I hold the wire centered in there, and it's 6 of one, half dozen the other. The amount of weight you're saving in that case is minute, if you're just talking about the little bit of solder inside the connector. But anyway, I use my old toothbrush here, and I just clean out any flux that's in there. The flux is corrosive. It's used to clean the metal, to clean the wire in the soldering process. Any flux that's left behind remains corrosive, so you have to get it out. Otherwise it will continue to corrode away at the joint. And with this one bullet connector attached, we just have to add a little bit of heat shrink. We leave the part exposed that has to go into the connector, the receiving end of the ESC. So I'll just use a heat gun. We'll shrink that into place. And that's our replacement bullet connector. Here's the original. You see it had the heat shrink over the top part. That's our replacement. And we'll do 2 more. We'll feed them through the frame and attach them. So for now, I'm going to stop the video. I'll finish the other 2 and we'll pick it up when they're done. Okay, it's later on in the day and we're back at the video. Before I left earlier today, I finished putting on these bullet connectors. These are replacement bullet connectors for the motor wires that we cut short. These were the original motor wires. And these were too long. They give you these typically with multi-rotor motors, just because in some instances you're going to have these inside of a long arm and you need that much wire, but when you don't need it, you're better off just getting rid of it and replacing your connectors. Okay, so the connectors are soldered into place. The solder joints have all been cleaned out. I've put heat shrink on each bullet connector so that they can't touch each other, you know, to keep things from shorting out. And I've put a little bit of heat shrink here in the middle of the wire where the zip tie is going to hold it in place. So that's just a little bit of extra protection for the wires. So let's see, let's put it through the spot in the arm. Okay, we've got some twists in the wire. Helps them to just stay together. Not too much though. Okay, and with these loose ends here, we can twist them a little bit. Alright, so now what we'll do is we'll just put the middle wire in, and that one can be pushed in all the way. Later on, when I'm ready to run the motors, I'll push these in a little bit, check the direction of the motor. If the motor's going in the correct direction, I'll push them in all the way. Otherwise, I'll take them out and just swap them over. So that one goes in all the way. And then what we're going to do is just put this wire into place. And I said earlier that I use this stuff. It's called backer rod. It's kind of a dense, springy foam. And I like to put it underneath things sometimes. Things that are susceptible to vibration, I try to isolate them from rigid, you know, hard plastic parts of the frame. So we'll just put that through there, get that all lined up. Now if I had something like this ESC, I wouldn't pack it in a ton of foam. You know, you can't just pack things willy-nilly in a ton of foam and insulation, because then you run the risk of creating an environment where they can't dissipate heat. So I'm just going to pull this snug. I'm not going to make it super tight. I'll use my wire cutters, snip that off, and like I said, when I'm ready to run the motors, I'll just put these in a little bit so they make contact, check the direction of the motor, and then either switch them to reverse the direction of the motor, or just push them in the rest of the way if it's correct. Okay, and that's my installation of a custom motor on the Flame Wheel. Alright, now I twist these motor wires. If you wanted to, you could braid them and then put a little bit of heat shrink on there to hold the braid in place. Let's see. Some people use the plastic, I forget what it's called, the twisty stuff that you put on. I have a roll of it. Some people use this stuff, cable wrap, and it's like a spiral wrap that you put onto your wires to protect them. This also keeps the wires together, but I find that this stuff, at least this product that I have, is very hard, and once you put it on the wires are not as flexible. So I don't really use it. I bought a lot of it, but I just don't use it. If there's one out there that's made of a softer plastic, you might try using that. But a lot of times this stuff is overkill. So as long as you're aware of, you know, what's going on with the frame plate, like this wire here, it's a little bit loose, but it's not really touching anything, and it should be in good shape where it's at. We'll finish up the other wires, If you have any questions, as always, ask your questions in the group build thread. And the next video, hopefully we'll be talking about getting the flight control set up in the NAZA Assistant. All right, thanks for watching.